finish those. I'll give you guys a little work time. Alright, so yesterday we graphed hyperbolas, right? Now today I'm going to give you the vertices, possibly the asymptotes, the foci. I'm going to give you two of the things. Okay, and then we got to come up with the equation. So just like those other three conics, we always plotted what we knew, right? Okay, so in this case we have vertices at 0, 3, and 4, 3. Let's go ahead, let's plot those points. And then if I have the vertices, what else could I get? Zero, 3, 4, 3. What else can I figure out from there? Just with that. Falls right in the middle. Center. Okay, that would put it at 2, 3, correct? There's my center. So, I got a center at 2, 3. And just with what I have now, what can I figure out? If I have the vertices in the center. Drew, what do you think? What else can I figure out?
I don't know.
Vertices. What always went through the vertices? The two branches, right? In a hyperbola. So if the vertices are left and right, that means the graph is going to open left and right, isn't it? Okay, so since it's opening left and right, which variable comes first? X or Y? Hayden? X, right? So, from there then, I'm just going to do what I know. Remember, this is HK, right? And X has to come first in this case. X minus 2 squared over something. And what was the sign in between the two terms on a hyperbola? Aubrey? Ellipse was plus, right? Hyperbolas are minus. So y minus 3 squared. What did it always equal? Ethan? 1. So we got to just figure out a squared and b squared, correct? Okay. Now, the distance and then the distances we're always looking for is center to whatever, right? Center to vertices. What's that distance right there from the center to the vertices? Maria? 2. And if we went left and right, is that going to go under X or Y? Ethan? Under the X. Left and right's X, right? Are we going to put 2 there under the X? A squared and B squared, right? Right now this is A. So A squared would be 4. So now I need to figure out B and B squared, correct? B squared is going to go right here. Now, this is where we're going to use that other point, foci. 5, 3, negative 1, 3. Okay. So this distance is what? Morgan? 3. Is that B? Distance from center to foci will be which one, B or C? Cole?
C.
C. Now, C is going to help us find B, right? This is where we're going to use the C squared is equal to A squared plus B squared. So C squared, that would be 9, correct? Is equal to A squared, which was 4, plus that B squared, subtracting that 4 over, 5 is equal to B squared. So B would be square root of 5. Do I really need B in this case? I'm looking for the equation. I want B squared, right? So I'm just going to go replace B squared with B squared. B would help us graph it if we needed to graph it as well, though, right? But if I'm asking for the equation, I'm not worried about that. It's always equal to 1, correct? Okay, so again, when it comes to writing equations of any conic, it's about understanding the different parts. What's A, what's B, what's C? Where's the center? Where's the vertex? Okay. Questions on that one? Well, what we know, figure out what each part is. Okay, so we have vertices here, 4, 3. Four, -3. Where's the center? This guy? 4, 0. Yep. There's my center. So what it comes down to is you need to figure out center, A squared, and B squared. Once we have those, we can write our equation. Okay? So if our vertices are up and down from the center, that means it opens which way, Matt?
Up and down.
Up and down. Okay? So since we're not actually graphing, I would just do a rough sketch to help give me a visual that, yep, it should open up and down. Meaning, which variable comes first? Caleb? Y comes first. So I can write about half my equation already, can't I? I know y comes first and I have the center. Y minus 0 squared over something minus x minus 4 squared over something is always equal to 1. Center of vertices now. What was that distance? Drew?
3.
3. Is that A or B though?
A.
A. Vertices is always your A, right? Okay. So if A is 3, that means A squared is 9. Now is that going to go under Y or X? Cody? Under Y. Going up and down, right? Okay, so that's under our Y. Now it's a matter of figuring out that A or B squared. So, both sides, what's going to help us there? 4, 2 root 3, 4, negative 2 root 3, 2 root 3. 2 square root 3, about 3.5. So that puts it about there, about there. Here's my foci. What is that distance? It's about 3.5, right? What's the exact distance though? What's that distance from center to the foci?
Oh. 3 and 2
2 root 3, yep. And that is what? B or C? Cool?
C.
That's our C. So again, C squared equal to A squared plus B squared. Okay? And we didn't know B. We know C was that 2 root 3. What would C squared be then? What's that? 12. 2 times 2 gives me 4. Square root 3 times square root 3, that's 3, right? So 4 times 3, which gives me that 12. So, at this point, I got 12 is equal to 9 plus b squared. Subtract that over. 3 is equal to b squared. So I need to get just b. Well, it would help us graph it, right? Because that's the distance I need to go left and right. But I need the 3 in the equation. Would I want you to leave it at that, like that though? With that y minus 0? Oh. So let's rewrite this as y squared over 9 minus that x minus 4 squared over 3 equals 1. So again, what it comes down to is figure out center, figure out a squared, figure out b squared, right? Sometimes if I give you the foci, okay, that's giving you C. If I give you the vertices, that's A. Okay. Alright. A little bit tougher. I'll give you the vertices and the asymptotes. So, let's plot those vertices. 1, 1, 1, negative 7. Okay, now put our center where? It's a distance of 8, correct? From 1 to negative 7, so half of that's 4. So 1, negative 3 for my center. Now, when you plot those asymptotes now, what should be a common point between those two lines? Morgan, what would be the common point between those two lines? 7, right? Those asymptotes always go through center. So, when I plot that now, 4x minus 7, I got a y-intercept of negative 7, up 4 over 1, that puts us at the center, up 4 over 1. Okay, so negative 4x plus 1. So 1 is our y-intercept, slope is negative 4, so down 4, right 1, down 4, right 1. What does that help us with, though? Do you see the box that we can make? Okay. We got that slope, right? If we got a point here, 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 and here, there's our box. Let's write down what we know so far. We got a center. We said 1, negative 3. Okay, we got our distance to the vertices. What's that distance from the center to the vertices? Mason? Center to vertices. What do we got? 4. Center to vertices is always A, right? Again, we need A squared. B now. Okay, if we got our box, that puts those points on that box, right? So what's that distance? Alex? 1. Do I need to worry about C in this case? I already got A and B, don't I? Okay. So the last thing we need to figure out, which way is it going to open? If my vertices are up and down, that means what, Hayden? It's going to open up and down. Meaning, which variable comes first? It opens up and down. This guy? Y. So, from there, y minus -3, so y plus 3 squared x minus that 1 squared equals 1. A always comes first, right? In the hyperbolas. And we went up and down 4, so the 16 needs to go under y, and the 1 will go under x. So plot what you know. Again, the big thing is to know your A, B, and C. Okay? And you need to find A and B. So if I give you the foci, you have C. You got to use the equation to find that missing one. Oh, is that it? Yeah. Okay. So I'm giving you guys plenty of time to be working, right? Aubrey, go ahead.